All right. Number 1, Mr. Wilcox is trying out a new beard oil to make his beard grow faster for No Shave November. At the end of November, his beard is 3 inches longer. He concludes that since his beard grew 3 inches, the beard oil must work. What is wrong with this experiment? Yes. There's no control. Explain what you mean by that. I agree. Just give me a little bit more.
There's no subject that isn't using oil, that isn't only oil. There's too many factors.
I like it. All right, so we don't know how much his beard would have grown with no oil. That's your point with there's no control here. So one thing that could be done to improve this experiment is we could measure beard growth for 1 month without the oil. That would give us our control there. Thank you. Any other thoughts on anything else that is wrong with this other than there's no control? There's a lot of factors, such as his diet. Anything else?
What type of oil he's using?
What?
What type of oil he's using?
What type of oil he's using?
We don't know when the last time he shaved.
We don't know when the last time he shaved was. So what's something that could maybe be done to control for those factors other than having a control group? What are your thoughts? Use the same oil
On someone else, yeah.
on someone else.
Use it, have more than just one person.
Have more than just one person. Yes, we could absolutely do that. If he's the only one that he knows of that's willing to try this, let's just imagine that for a second. I'm not saying you guys are wrong. I like what you said. But if he's the only person that's willing to try this, how could we maybe control for those things? If I can't get somebody else to come along, could we still run an experiment with just one person?
Yeah.
Yeah. What could we do?
One side oil, the other side not.
Ooh, I like that. I like that a lot. Could also do this for more than 1 month. I'm going to come back to that one side oil, one side not oil later, because I really, really like that. So he could do this over the course of more than 1 month. That would try to help control for diet and other things that might change. Maybe 1 month he goes out to eat a whole lot, and that doesn't do good things for his beard growth. And then in another month he cooks at home, and then the third month it's kind of split half and half. We want to make sure that we have control and replication. We want to make sure that the results that we see aren't just a one-off. This is repeatable. Doing this for more than 1 month, where he does one side oil and one side not oil, would help with replication and control. All right, let's look at number 2. The track coach decided to offer the track athletes 2 options for daily workouts: a rigorous strength building workout or a relaxed workout of mostly stretching. After 2 months, the athletes that chose the strength building workout were 11% faster, while the relaxed workout group was only 3% faster. What's wrong with this experiment? The people who chose the strength build might be more motivated. What would we call that? I like that. This is voluntary. This isn't. There's no random assignment. What you were getting at is there could be a confounding variable here. So absolutely, athletes got to choose which treatment. And if they're choosing, is this actually an experiment? Observational study, not even an experiment here. Describe an appropriate method the coach could use to randomly assign the 2 workouts to the 120 athletes. What's the first thing you would want to do if you are going to randomly assign 120 athletes to one of these 2 workouts? Assign what? Assign them numbers from 1 to 120. So number the athletes or label the athletes or assign a number to the athletes from 1 to 120. All right? Once we have everybody labeled with a number, what do we do?
Use a random number generator to choose a number of unique numbers.
60, right? 60.
You want to do
You're
60?
doing it as
12, 10%. 12.
well, if we're doing all of them need to be in a group. So
Oh,
you
I would
split it in half.
split them. Oh,
Yeah.
split.
So
split
60 for one and 60 for the other.
I love this.
I was jumping.
Okay, so use a random number generator to,
Split the groups. Or you should split first and then use the number generator.
But you're randomly splitting them, so you gotta randomly choose a random number generator to randomly pick 60 numbers with no repeats.
yes. Yes, use a random number generator to select 60 numbers with no repeats or 60 unique numbers between what and what? We have to give our upper and lower boundaries. Between 1 and 120. Use a random number generator, generate or select 60 unique or 60 non-repeating numbers between 1 and 120. Either having the word unique or no repeats in there is really vital, as well as giving the lower and upper boundary of what you would give to this random number generator. Okay, so now I have 60 numbers in front of me. I have athletes that have each been assigned a number. What do I do now?
Is he doing like a sample, or is he's assigning them to all of the 120, not like a sample of the one of the 60 or a sample of the 60?
Correct. We're not doing a sampling here. We're not just taking some of our group. Everybody's going to get assigned to one of these treatments. So what are we going to do with the 60 numbers that we have now generated using our random number generator?
Assign them to a group.
Figure out the people who the numbers assigned to.
We need to correspond the numbers to the people, and then what are we going to do once we've picked out the people that this goes to?
Assign them an exercise.
Assign them. Which group should we put them in?
The workout, the strength building.
Strength building workout. I like that. The athletes corresponding to these numbers are assigned to the strength workout. And this last statement needs to be made. It feels like it would be intuitive, but it's not. You have to actually state this last piece. So I've got 60 people in the strength building workout and 60 people that are sitting on the bench.
Repeat for
Not repeat, but assign the other numbers. Assign the people who have the other numbers to the other workout.
There we go. We're going to take the 60 people that weren't selected, the remaining athletes, and assign them to the relaxed workout. If we had more than 2 treatments, we would need to repeat the process.
Great teamwork, Jamie. I missed every single one.
You had some good ideas.
You said earlier it's a rough day.
What is the benefit of using random assignment?
Low bias.
Hopefully.
Oh wait, so
When I'm picking out a sample, yes. When I'm picking out a sample, this would reduce bias, that random selection. We didn't pick out a sample. We used everybody that was on the team, and everybody on the team was assigned to one of these 2 treatment conditions, either the relaxed workout or the strength building workout. Why are we randomly assigning them to these different workouts? Why not just have everybody do the same workout? What's the purpose in doing this random assignment between the 2 groups? What do we want to know? What'd you say?
Is it an experiment?
It's an experiment. So what question are we trying to answer with our experiment?
Which one's
Faster
better?
afterwards.
Which one's better for building? For becoming faster?
Which one makes them faster? There's one particular word that I'm looking for here that starts with a C. The purpose of doing an experiment is so that we can determine
What
causes what else. Yes. So the benefit of doing our random assignment is so we can show that the strength workout caused the faster times. With the way the coach did this to begin with, all we know is there's a correlation between the strength building workout and the faster speeds. But we don't know that it was the strength building workout that caused it, because there could be confounding variables. When we do an observational study, there can be all kinds of confounding variables that are actually the true cause. Doing an experiment doesn't get rid of confounding variables, but it should sprinkle them equally between the two groups so that the two groups are the same in their overall spread. And the only difference between the two groups, not between individuals in the groups, but between the two groups themselves, would be which type of workout they were assigned to. So far, so good? All right, let's go look at number 3 then. What's wrong with this one? On a recent test day, an AP Stats teacher wanted to determine if smart pills would improve grades. As students walked into class, they were randomly assigned a pill that said either smart pill or sugar pill on it. The test scores were significantly higher for the group of students that took the smart pill. What would we call the sugar pill? Placebo. So what's wrong with this experiment? That's exactly right. Students knew which treatment they were getting. So what could be done to improve the experiment? What'd you say?
It was randomized, but like don't have them be labeled where they can see it.
Yeah, we were randomly assigned here, so we're good there. But I heard labels, right? Remove the labels. No labels on the pills.
Yeah, it's in it.
The pills had either smart pill or sugar pill printed on them.
But it doesn't say they knew.
How about it wasn't hidden from them? Whether they chose to read the pill or not, it wasn't hidden information. If there are no labels on the pills, so that the students don't know which pill they're getting, does anybody know what we would call that? Single blind. Yes.
That's psychology.
Yep, I was going to say, if you've done AP Psych, you've probably talked about this. Right?
With this one, we can, with these ones, we can tell which ones took psychology or not.
Will they ever call you? You said he always calls you and asks you questions.
He hasn't called me yet this year.
Okay.
Not yet this year, but yes. Almost every year he's got questions about the statistical analysis of the studies that you guys have to turn
Did
in.
you get a lot last year? Because they changed the coursework a little bit, so he was a little more...
I was getting questions about ANOVA testing, which is not something we cover in AP Stats. ANOVA testing is a way to do statistical tests with categorical variables as opposed to quantitative variables. What would we call it if the students didn't know which pill they were getting, but neither did the teacher?
Double blind.
Double blind. Double blind if the teacher also doesn't know. Someone would have to know, but it wouldn't be the teachers or the students. Basically, the participants don't know, and the person directly interfacing with the participants doesn't know. Why do we care about single blind and double blind? Why would you do that? To remove bias. Absolutely, to remove bias. You don't want the knowledge of which treatment a person is getting to influence their behaviors, and you also don't want the researcher that is interfacing with the participants to somehow influence the responses of the participants. That's why they use placebos. Sometimes you'll even have a study where you have a straight-up control group that gets no treatment. Well, no treatment would be a treatment, but they receive nothing. You have a placebo group, and then you have a group that is getting the active ingredient treatment. So you can compare specifically, what is it when we have nothing? What is it when we have just the placebo effect taking place? So how much of this is just, I know I'm taking a treatment, and then how much of it is the actual medication? All right, let's go ahead and flip this over onto the back. Well-designed experiments. There are 4 components to well-designed experiments. Comparison. You need 2 or more treatments. That was the big issue in problem number 1 on the front side with the beard oil. He had only 1 treatment. He was using the beard oil. We didn't have that comparison. Random assignment is another really important part of a well-designed experiment. We need that random assignment to help control for other potentially confounding variables. Replication, there needs to be more than 1 in each treatment group, or in the case of the beard oil, if there is only 1 person, you need to do this over multiple months so that you have replication. And control, you want to keep all the other variables constant. Random assignment, label, randomize using your random number generator, or if you do names in a hat, you'd mix them thoroughly, and then you assign. We do this to show causation. Make sure you assign all of the treatments. So if you have 2 treatments, and you say we're going to pick out 60 numbers, and we're going to assign the students that are associated with those 60 numbers to group A, you have to then also say the remaining students get assigned to group B. You have to assign every participant. Placebo effect. When a fake treatment, a placebo, works. Blinding. When subjects, single blind, and or experimenters, double blind, don't know who has which treatment. That doesn't mean nobody knows. And this is one thing that I definitely want to clarify. When you take the test and I'm asking about this stuff, please don't tell me nobody knows who got which treatment. That would be a worthless experiment. If we don't know who's in what group at the end, then I cannot compare the results between the 2 groups. So somebody would have to know what's going on, but not the participants and not the person interfacing with the participants. Some third party would have to be able to match up who got what treatment. All right, check your understanding. I'm going to give you guys, let's see, there's 4 parts to this. Why don't we take 8 minutes? 4 parts take 8 minutes, and then we will go over the check your understanding. Yes. Grab one of those markers. Yep. Name, date, and time. Thank you.
Would you say use NRNG or would you say use RNG?
I would say NRNG. Yeah. there's only 3 groups, you randomly assign the first, take those people out. Repeat to randomly assign the second, take those people out, and then all the remaining ones would get assigned to the third group. If there's 4 treatment groups, then you would randomly assign the first, repeat the process for the second, repeat the process for the third, and then take everybody else's on the fourth.
So can I just say repeat process for group 2?
Make sure you're giving it in enough detail that if I were to follow your process, I'm going to end up with the right number of people in a group. Yes. Oh, when data gets back, yes.
Why is it important to have a control group that didn't get any marks on their rears?
So the researchers could compare how many deaths would normally happen against counts of that.
Yep, a control group provides baseline data, so we have something to compare to. Absolutely. We want to know how many deaths would happen without any intervention at all, or what proportion, maybe not number, but what proportion of deaths could be attributed to no treatment conditions here. Suppose the researchers had 1,200 cows. Describe how to randomly assign the cows to the treatments. First thing, label the cows from 1 to 1,200. You do have to say, you can't just say label them, you have to say label from blank to blank, lower and upper boundaries. Just like when we talk about our random number generator, we have to give the lower and the upper boundaries. Okay, now that I've got all the cows labeled, what do we do? Yes. Use a random number generator to generate 400 unique numbers between 1 and 1200. I left that out and I shouldn't have. Between 1 and 1200. Okay, so after we have selected these four, why 400? Yes, we want 3 groups, so we picked 1/3 of 1200, which would be 400. Now that I have 400 unique or 400 non-repeating numbers, what do we do with those 400 unique numbers?
I said match the cows to their numbers and then use the first 400 numbers. Oh, wait, I said repeat this 2 more times without replacement. So that way you get.
Repeat 2 more times without replacement. You can say that at this point, yes.
And then I said match the cows to their numbers and use the first 400 numbers as a control group, the second 400 numbers as crossmark cows, and the third group of 400 as with the cows with the eyes.
Yes, I like that. The only thing that I would maybe change just a little bit, rather than say the first 400 numbers, the first 400 selected numbers. Because we want to make sure that they're not just going to go from 1 to 400 and from 401 to 800. You want them to use the numbers that were selected by the random number generator. So you can select your 3 groups first and then assign them, or you can select your first 400 numbers, assign it to a group, then repeat the process to assign to a second group, and then assign the remaining to your third group. So assign the corresponding cows. I had my first group get the eyes. If that was your last group, that's fine. You just want to assign one of these 3 groups to get the eyes. And then I said repeat the process to select 400 different cows to get crosses. And finally, all the remaining cows would get no marks. You might have assigned your first group to get no marks, your second group to get the crosses, and your third group to get the eyes, or whatever. It doesn't matter what order you assign these things in, as long as you can look through your random assignment directions and find where you have talked about all 1,200 cows. You need to expressly assign to all 3 groups. Okay. Then we get to part C. What is the purpose of randomly assigning treatments in this context? We want no bias, but that's not the purpose of doing an experiment. Yes?
So we can show that the eyes on the rear cause no death.
Yes, we want to look for causation here. So we can determine if the treatments cause the deaths to decrease. Maybe it could just be any marking on the rear. It's not necessarily the eyes, right? It could be eyes or crosses, just if they have any markings on their rears. Maybe that's what's causing the deaths to go down. Maybe eyes is more effective than crosses, and crosses is more effective than no markings. Yes?
Can we use that first part universally so we can determine if the treatments cause that universally and then put what we're looking for?
Yes.
So for, in this case,
Yes.
deaths to decrease.
Yes.
Okay.
We are randomly assigning so that we can determine cause. We want to hold everything else the same between the groups. That's why we're randomly assigning, so that we can kind of equally sprinkle the possible confounding variables between all 3 groups so that the groups are basically identical. And the only real difference between the groups would be what kind of marking they got. Describe a completely randomized design for the experiment. So this stays almost exactly the same. Label the cows, use a random number generator, assign the corresponding cows, repeat the process. All remaining cows get no marks. But there is one more thing that you would need to do in order for this to actually classify as an experiment. What do we have to do after we assign everybody to their groups? Conduct the experiment. And what's the necessary last step in conducting this experiment? Yes. After, in this case, 4 years, because it said these cows they let go for 4 years, compare the number of deaths between the 3 groups. And the only reason I picked 4 years is because when I was reading the text up at the top, it said after 4 years of roaming the plains, the cows with eyes, the cows with crosses, the cows with no marks, and it talks about the number of deaths they suffered. Could you do this in a shorter amount of time? Could. I don't know what kind of results you would get, but you could. The longer your experiment goes, the better it is. Sometimes we don't have 4 years to give up. Maybe they only have 1 year that they can spend on this experiment. Then they would compare the results at the end of 1 year. All right. Anytime you are asked to describe an experiment, the first thing you have to describe is how you will randomize. And then the last thing you would talk about is the comparison that happens at the end. If you are asked to design an experiment, talk about how you will randomize the treatments, and then talk about comparing the results at the end. All right. That is all we are covering for today. There are 2 types of experimental design beyond just a completely randomized design that we've talked about right now that we will discuss tomorrow. This gets into your beard oil, one side and one side. That would be a specific type of experimental design called a matched pairs design, where you have taken one person or 2 people that are very close together, maybe not identical, but close to it, and you match them together and they get each of the treatments randomly assigned. We will talk about another type of experimental design called block design tomorrow, in addition to matched pairs. And then homework is due on Wednesday. So unless it's talking about a type of experimental design, block or matched pairs, you can do it on the homework. The only things that we haven't talked about are those 2 things there.